All right, so we're going to continue Project 2 in Python. In the last lecture, we got through Task 2, and then we were about to start Task 3, and the class asked a bunch of really good questions, and we just got sidetracked and started talking about stuff. So I'm fine being sidetracked. I'd prefer that, actually. We ended up talking about like 220, 250, programming languages, things like that. So anything you want to talk about, we can do that. By default, with no questions, I'm just going to be ripping through Project 2. So I'll be watching my phone, watching your hands, and otherwise I'll just be going through this. Anyone have questions before we get into it? Yes. Yes. So CSE 250 is going to be in Scala this semester. Next semester, 116 is switching to Java, and then the following semester, so in 2 semesters, 250, as long as everything goes according to plan, will be switching to Java as well. So you're like the last class that's going to get Scala and Scala. Next semester, it's Java and then Java. But 250, in general, is taught in the same language as 116. So it's 116 switches, the next semester, 250 will switch. 220 will be in C. So 220 will be a brand new language, and it'll be your 4th programming language. Which I'm thrilled about, honestly. So what I went through, I don't know if I've talked about that in this lecture, but I did my undergrad here. I went through these same courses starting in 2008, way back when. And 115, 116 were both in Java. 191 didn't have any programming. 250 was in C++, and 220 didn't exist. So by the time I was done with 3 semesters, I knew 2 languages, Java and C++. And I think that was a big shortfall of the curriculum. So now by your 3rd semester, you'll know 4 languages, or at least have been exposed to 4 languages. How much you remember of JavaScript is probably very little. What you remember of Python, what you could do in Python is probably almost certainly a lot less than what you can do in Scala right now, just because you've been using Scala all semester. And you'll use it again next semester, so your Scala will be pretty sharp. And then your C will be pretty sharp after going through 220. But you'll have been exposed to a lot of different ways of thinking. Before it was Java, Java, C++, and we never really learned programming. We just learned Java syntax. Like, we all memorized Java syntax, and we get things done in Java. And then when they threw C++ at us, it was just a real bombshell. Like, we just didn't know what to do. It was a big struggle to go from 116 to 250 before. To address that, we make sure that 116 and 250 are the same language now. So 250 is introducing a language, which is a lot better. A lot better. But then we added 220, which is introducing a language anyway, so somewhat messed up on that. Any other questions? I'd be happy to just ramble about anything. Yeah. What are the differences between Scala and Java? Between Scala and Java, maybe we should have done one of these days going through homework 2 in Java. The difference between Scala and Java isn't too much. Because they both compile down to Java bytecode, there are a lot of really striking similarities. So now that you know Scala, one thing that I always say, and I'll say again right now, knowing Scala and then trying to learn Java from Scala should be really easy. You should be able to pick up Java quite easily. So most of your Scala skills will transfer over. The syntax is a little bit different in places, and one of the big just general differences is that Java is more verbose. Like, it's going to be more explicit with a lot of things, which I think makes it better as an educational language. So I'm excited to switch back to Java and get all those very explicit things. Like we're about to see a couple, one of them at least, in Python right here. Python and Java both make the super constructor calls explicit. Actually, is that true? I think Java might be optional. I'll have to look at that. I'll make it explicit in my lecture notes and everything when I do it. But the super constructor call is explicit. So like in Scala, you have to remember when I extend this class and I'm doing my memory diagram, I have to remember that that stack frame is going on the stack as a separate method call. In Python and Java, that's explicit. It has to be there. Scala has type inference, so your variables don't always have to have their types explicitly mentioned. Java, not getting away with that. Java, you always have to mention your types of your variables. So again, I like that. I've been mostly consistent with that throughout the semester. I've always added my types, even when it's redundant, even when it could be inferred. But Java's going to make you add that type for every single variable. It can't be inferred. So a lot of things like that, where Scala, I would prefer coding in Scala, by the way, because Scala is going to cut out a lot of that redundancy. With Java, it's just a lot more typing. It's a lot more physical typing. And if you know what you're doing, it's just extra work. But for an educational language, I want that extra explicit everything. Because it's going to make things a lot more clear to students, I believe, and I hope anyway. Any suggestions for finding internships? One, find them. Do find them and do apply. It's a bit late right now. What semester is this? We're in a fall. So it depends on how all your things line up. You might be able to apply right now-ish, but hiring season, at least for the major companies, is like October, November for the following summer. So like this past October and November, that's when they were hiring for summer 23. So next fall, for sure, if you're looking for internships, next fall, absolutely, you need to be finding these and apply. Try to get yourself an internship for summer 2024. No question at all. It's a little tougher to get them as a freshman, but depending on how your things line up, you'll be 3 semesters in by next summer, so maybe you could still get one. And with the smaller, local companies, they tend to hire in the spring. Their hiring season will be a lot later, so you can find those. As far as finding the internships, the best strategy I've found is going to a company that I want to work for, go to their website, find their careers page, and search for the software development internships, and actually find them there. You can try going to, I forget what it's even called here, but the job site at UB. You can try searching there. You can try going to the general sites. You can go to LinkedIn and Monster.com comes to mind for some reason, and just search software development intern and go there. But everybody's doing that, so you're not going to stand out at all doing that. And some companies won't post their internships there or their regular job openings there at the mass sites, because what people do, and I've talked to quite a few students who do this, they're really completely open about it, unashamed about it. They'll just search software developer and apply to every single one. I've talked to students who will apply to hundreds of openings and just hoping something's going to happen, that somebody's going to offer them a job. Those applications are usually pretty easy to spot on the other end when you're filtering through applications. The person who mass applied to everything, there are things about it that just stand out, and those usually just get thrown away. But if you're, applying to a company through their website, they're going to see that in the application. They got applications coming here through the job search websites, and web applications coming in here through their own website, and there are going to be a lot fewer here, and it's going to weigh. Usually, I'm speaking in generalities, of course, it's going to depend on the company and everything, and the actual person reviewing the resumes, the hiring manager and everything. But generally, this is going to have a lot less flow of applicants, and it means more because these people aren't the ones just mass applying to anything. The fact that they went to your website means that they have some specific interest in your company, in your position. So if you're looking to actually work for that company, find that company's website, go to their careers page, and apply directly to them through their website is something that can give you an edge. And then two, I was doing a numbered list, I forgot. Two, personalize it to that job. Like your cover letter, don't just have a generic cover letter. Say, I want to work at your company. I read your job posting and it said you're looking for this. I got that. Like actually personalize it at least a little bit. You don't have to go ham with it. You don't have to go overboard, but at least a few things at the beginning of the cover letter. Make sure that you're personalizing it. And those things can give you that first edge and get you actually considered and not thrown out immediately, not your application thrown out immediately. That's my advice on that. I don't want to go too far on that. I could go all day with advice on finding a job in general. I don't want to go too far just in case that's not what's being asked. But going to the company websites for sure. Any other questions? I'd rather field questions like this than just go through some Python code. But if not, I'll go through Python code. I'll be watching my phone, so if you want me to get sidetracked on something more interesting, we can do that. There is one thing I want to make sure I get in Python is the syntax for inheritance. I kept saying we're going to do inheritance and polymorphism today, but polymorphism really doesn't exist in Python. Like it kind of does, I guess, but not really, because Python is not strongly typed. Where polymorphism really came into play with Scala was because Scala is strongly typed, and we could have a variable of type modifier and have it store either a sale, a sales tax, or a bottle deposit. We could have a list of modifiers and mix these three types in that list. Well, Python does that out of the box. Like we don't need polymorphism to have a data structure storing different types. Lists in Python just do that. So we really don't get any benefit from polymorphism, but we still have the benefits of inheritance, where we can inherit a class and get all the state and behavior from that class. So let's see the syntax for that. Let's create our modifier. I'm just going to set up my files real quick. Modifier, sale, sales tax, bottle deposit. In our modifier, class modifier, and that's really all we need. We could just do pass right here. We're not actually going to see, for this application, for task 2, like it meant a lot for Scala because our goal was polymorphism. But in Python, it actually doesn't do anything for us. So I'm going to add a little extra stuff just to show you that we are doing inheritance. So def init pass. And this pass is not just a placeholder. This constructor isn't going to do anything. In fact, we could just leave off the constructor entirely, and that'd be perfectly fine. Def update price takes a price. Pass def compute tax takes a price and pass. So there's no concept in Python of an abstract class. Abstract is not even a keyword. We don't have abstract methods. Doesn't mean anything. So we're defining a regular class with regular methods, and then I'm going to do pass because this is effectively my abstract method in Python. I'm just going to do pass, leave the body completely empty, and just say this method doesn't do anything. Yeah, it will when we extend it and, quote, override it. Does a lot of LEET code questions give us real ability to work in industry? This is a bit debated. My opinion, I'll preface this with my opinion. I guess everything I say is my opinion for the most part, but I don't think it matters all that much. In industry, you're working on large code bases and you're working on a team. And those are two things that you just don't get with leak code questions. Leak code can help you with your algorithms and data structures and that type of thinking and coming up with creative solutions to complex problems, which can help you with the coding interview. So if you want to apply to a place like Google, who's going to put you through a grueling coding interview when you apply, for those, actually, you might not know this. Let me back up a little bit and explain that. Google and several other major, like the huge corporations, they'll put you through the coding interview. So when you interview, I heard it's a little different now, but it's effectively the same. When I did it, it's Google Docs. They'll share a Google Docs link with you. You open Google Docs. They give you a coding question, which is going to have some complex data structures and algorithm implications, and they're just going to say, code it. In Google Docs, I don't think it's Google Docs anymore, but it's something effectively the same thing. You don't get syntax highlighting, you don't get autocomplete, you don't have any of the tools that an IDE would provide you. You just get a text editor with plain text, and you have to code it while you're on a voice call with the interviewer, and they'll be talking to you as you're going through this coding question. So being sharp with your data structures and your algorithms, all of your asymptotic notation, because you can guarantee, just about guarantee, I shouldn't say guarantee because I don't know, but every single one I've ever seen or heard about, at the end, you're done coding, you're going to be like, okay, I got this. Coded it, it's good. They're going to say, what's the asymptotic runtime of what you just wrote? Then you're going to have to analyze the runtime, and then they're going to say, can you do any better on runtime? And sometimes if you have the optimal solution, you can just say, no, this is the optimal and this is why. Or if there is a more optimal solution, they want you to get that more optimal solution. So that's the coding interview. So Leak Code is going to help you with that. But that interview process is also in contention, and some of these companies are moving away from it because they're finding that it doesn't do a great job of selecting the highest quality employees that can work on large projects in a team and working on a project over months and months and months. And I've seen students like this. I had one student in particular that always comes to mind. Obviously, I'm not going to share their name. They were good at like Leak Code questions. They were great in hackathons. They built some really cool stuff for hackathons when it's a 24-hour event. But once the project grew beyond 24 hours, because I wanted them to work on the Autolab project, once the project was more involved and was longer term, they just completely couldn't do anything. I believe the issue was that it just wouldn't hold their focus. Like they couldn't focus on a single project for more than a couple of days. And they could make it for like a homework, like a weekly homework or something, or a project, but they couldn't just think about and work on this one project for more than a week. They lasted 1 week with me. They didn't really do anything. They lost interest, and I said, this isn't working out. So those skills are tougher to, let me try to cap this off so I'm not talking about this the whole time. But those skills that are needed in industry are really hard to find through the interview process. There's just no really good interview process that we know of yet to be able to discover if you're going to be able to work on a team on a large code base for a long period of time. So companies do what they can. Most companies, by the way, besides the major, huge, mega huge top corporations in tech, most of them have pretty casual interviews. They just talk tech with you. More casual than the I don't know if that's a fair comparison, but more casual than the 116 interviews. Like we could do coding interviews for 116 for your labs, where we say, find the midpoint of a linked list, and then you have to go like to the whiteboard and write your code. Like we could do that style. I don't want to do that because I don't want to see everybody fail, honestly. But because that would be tough. That would be difficult. But we keep it a little more casual and just ask you about the concepts. And then more casual than that, that's what most actual interviews are from just everything I hear, everything I've experienced. That's where the tech interviews actually are for most organizations. But you do need to be able to talk tech, which is what the interviews in 116 are prepping you for. You need to be able to talk tech. If somebody says, I'm going to, because this is what you'll do, here's like a conversation you'll have on your job all the time. How are we going to design this code? Well, I was thinking of creating an abstract class and then extending that with the other classes so they'll share that behavior. And then we'll have polymorphism over here. Maybe they won't use polymorphism or those exactly, depending on the language, but knowing what those words are and being able to use them in conversation and be able to collaborate with somebody, come up with ideas, using all that vocab and stuff, that's really important. And that's what most interviews are going to get. Here's what I like to do in an interview. I'm looking at the resume. Oh, I see you did this project. I see you created a mod in Minecraft. Can you tell me about it? And they'll be like, oh yeah, we built this item, blah, blah, blah. And then I'll get to the more tech stuff. Okay, so how did you actually code that? Tell me what tech you used and things like that. Oh, I used Java and this is how I built it. And then I want to know the details. Can they carry on that conversation and talk about the tech stuff that they did in their life? If they can, I'm happy. If they can't, that's a big red flag. All right, I went too long on this tangent. Oh yeah, the STEAM fairs for sure. The STEAM fairs, are they all online now? I feel like they're all virtual. We used to have the big fair, the job fair in the gymnasium over in Alumni. It was just all kinds of tables set up and there were all kinds of employers. Does that still happen or is it all virtual? Does no one know? Well, was all online? Okay. Okay. Because I have advice for the in-person ones, but if those don't exist anymore, I'm not going to bother. But yeah, go to the job fairs. Talk to the companies that you're interested in. All right, I'm going to go back to Python. No more questions, and I ran out of stuff to say about that. I'd be happy to ramble for 50 minutes, though. That's the kind of mood I'm in today. But we got to get at least one of these. I did mention we have to get to the inheritance, which is right now. Class, sale, and then parentheses. So this is normally where we would expect constructor parameters. In Scala, in Python, completely different. Parentheses after the name of the class. This is where we're going to specify the class that we're extending. So this is read class sale extends modifier. That's how we're going to read that. It's one of the rare cases where Python is less explicit. Usually Python likes to put English words right in the code. Like a for loop is for, like instead of a colon that we read as in, it just says in. This is one case where Python goes backwards. Instead of putting extends right here, we put this in parentheses. And then we have to get our import in here. That's the error that I have. Model.items.modifier. So now I'm extending modifier, which doesn't do anything. I have two methods that do nothing and no state variables. So just to show you that this is doing something, self.state var equals 12. Let's get a state variable just to prove that we are actually extending something. And I want to go to my testing here. I don't want to do too much testing, but just to show off what's happening here, prove that we are actually doing something here. And just a little side task here. Let's get our compare doubles in here because I'm going to want this in a second. At that fabs d1 d2 less than epsilon epsilon equals 0.001. For prices, I'm fine with 1/10 of a penny for our purposes anyway. If you're working for a major corporation with millions of transactions an hour or so, you're going to want more precision than 1/10 of a penny, but for our purposes, I'm fine with that. And let's create a 10% sale. And we only have one piece of functionality here. I want to prove that my sale, when I create a new sale with the sale constructor, my sale is going to have that state var equals 12. Let's get a little bit more of our sale class here, just so I can get rid of that error, and then we can run that test. Oh my God. Percent off. Pass. I think I can get away with that warning for now and run this. Sale has no, oh yeah, no, I can't get away with that warning. All right, so I have to talk about this first before we get into, before we can run that test. So in Scala, you extend a class, and you just had to remember, this is going off what I was talking about with Java. In Scala, you just had to remember that the super constructor was called. When you have that extends and then the super class, you had to remember that that was actually a constructor call right after extends. Python says, no, we don't like mysteries and surprises and all that stuff. That's why we have self explicitly right here. So just like that, you have to explicitly call the super constructor. So that's the warning that I'm getting here. And without that super constructor call, I really don't have inheritance here. You saw that I didn't have state var as part of the sale object that I created. So we have to explicitly say super.init and call the super constructor. Without that call, the super constructor is never called and it never happens. So we have to be explicit here. We have to actually call that constructor, which makes things a lot easier. We're doing our memory diagrams, and this constructor is called. You have your parameter here. We might as well do our state variable while we're here. Self.sale percent equals percent off. We have our state variables explicitly going over to the heap instead of just implicitly, magically appearing over on the heap because they were constructor parameters. And an explicit call to the superconstructor. So when you get to the superconstructor call, you know you're calling another method, you know to create another stack frame, you know what the arguments are, what the parameters are going to be. All that stuff is right there explicit for you. Where Scala is helping us out, like it's like, no, I know you want to call the superconstructor because of course you're going to, so it just does it for us. Python's like, no, let's be a little more explicit so our code is more readable, we actually can see what's going on. So we're going to call the superconstructor. And I was confused about this in the previous lecture because I swear I had a bug where you couldn't do this. But you can put the superconstructor call where you want. So this can change the order of things. If the superconstructor call is first, then state var is going to exist right here. But if I try to put code up here, state var is not going to exist yet because it wasn't created yet. It wasn't added to the heap because I don't have the superconstructor call yet. So you can control where that is. I thought it always had to be last. I think it must have been the specific thing that I was doing with my code. Now we're ready to run our test. And nothing happens, yes. So when we run our tests, the way the asserts are, nothing happens, and we're cool with that. If we change this, we can see that the test is going to fail now because it's not working right. If nothing happens, that means all the tests pass. All the asserts pass, everything was good. When I'm writing testing, I always want to see my test fail. Every test I write, I need to see it fail before I'm feeling good about that test. This is a habit I recommend everybody gets into. So if I run this, in Scala, with Scala test, I would see a green check mark and green all over my code and everything's good. In Python, since we're not using a testing framework for this example, just nothing happens, nothing's printed to the screen, and that means the test passed. But I need to see this test fail. Once I see it fail, so I'm going to change it so the test is intentionally broken, run it, see it fail, and now I have confirmation that my test is actually running and testing what it's supposed to be testing. Because if I can change this value, if I can change this to the wrong value and my test still passes, I know I'm not testing anything and that I got something to work on with my test. So I recommend everybody gets in that habit. Always see your test fail. So my test is failing, so I know it's actually testing something. I change it to the right value. Now I have confirmation that sale.stateVar is actually what I expect it to be. It is actually this 12 because my test is actually testing that it is the value 12. I'm feeling a lot better about that. If that doesn't fail, one common thing to do is forget the assert. One thing I've seen 116 students do fairly, not too often, but I see it a few times this semester, is having all their testing code outside of a test. So you have your test and then the name of the test and then a block of code where all your testing goes. They'll have all their testing outside of that actual test. So it's not actually testing anything. And they'll get past your solution, past the correct solution, and also past every incorrect solution. And no matter what they do to their test, they can never get it to fail an incorrect solution ever. But they can also never get it to fail their own code. If you just make sure that you see your test fail, you'll never have that issue. You'll never make that mistake. I mean, you'll make that mistake, but you'll catch it right away. You'll change this to a 14 and say, like, for example, actually that won't work, will it? For example, if I forget to call this method, like this could be a mistake with this setup that I would do. I forget to call the method. I run it. It looks like my test passed, but since I changed this value and I can't see my test fail, I know something's up. I know I got something to fix. And it's because I forgot my call. I'm going to see my test fail. Okay, my test is actually testing things. Set it back to the right value and then see it pass. Now I know, I'm confident, I'm feeling really good now that that test is actually testing my code and that my code passed that test. Feeling really good about that one. Always see your test fail. Strongly, strongly recommended. And that confirmed our inheritance. So modifier declared stateVar. We inherited the stateVar. We did all that to prove that it is actually being tested. It is actually the value 12 inside objects of type sale. We're feeling good that that test is actually making sure that that's doing the right thing. All right. And let's get I'm actually going to copy and paste these so I don't have to keep typing. Now, in Python, there's no override. Everything's just kind of implicit and kind of made up. We actually don't even need that modifier class at all. We could just create our 3 sales tax, and battle deposit. And as long as we're careful about naming everything correctly, setting everything up the way we want, everything's going to work fine. But just to follow the homework assignment, I have my modifier, and so we can talk about inheritance. I got my modifier class. So compute tax, I'll do this one first because it's just return 0.0. And update price is going to return price minus price times self.sale percent over 100. I'm going to put my 0.0 to make sure I don't get integer divisioned. I shouldn't, because percent sale should be a double, but just in case. I mean, somebody might give it an int. Actually, I might have given it an int. No, well, because I'm just always careful about that. But if I give it an int here, Python's just going to store that as an int. Python ain't going to care. So I'm going to add my 0.0s wherever I can to make sure that I'm not getting jammed up on that. So price times sale percent minus that should give me what I want, right? And instead of staring at that equation all day, I'm going to write a test for it. Assert. compare doubles, sale dot update price of 100 should be 90. Like I'm missing something there, but I guess that's all I need. And I want one more test here. I'm going to do this. Call it twice. I'll set this up a little janky here. I'm not concerned about the structure of my test for this one. Call it twice and make sure I get my compounded updating price. So let's run this. Nothing happened. So I'm tentatively feeling okay about it, but I'm not sure. I'm going to change my test, see it fail. Now I'm really confident. And same thing, let's check this one. Just change it a little bit, make sure it fails. Okay, now I'm really confident that these are testing my code properly and that my code is doing what I expect it to be doing. Okay. So that's sale. Do sales tax and battle deposit. I don't have much more to talk about this. It's just kind of redundancy of doing the same thing 3 times. It was important for your homework because this is the first time you saw a type hierarchy. So I wanted 3 classes that are all extending one class so you can see how inheritance and polymorphism work. But as far as doing this in Python, and I don't have too much to say here. So let's just rip through this. Percent tax. Tax percent, update price just returns the price unmodified, and tax is price times self dot tax percent over 100. And that's it, right? Price. So if tax percent is 10, this is 0.1. Yeah. Cool. Battle deposit. Deposit amount. I just forget if there's 2 M's or 1 M in amount. It's not giving me a green squiggle, so it looks like I'm good. Deposit. Update price just returns the price unmodified, and the tax is just self.deposit. All right, so the next part of task 2 was to add modifiers to the item class. Def add modifier, takes a modifier, and self.modifiers.append, we just jammed it into that list of modifiers, which doesn't exist, so let's make it exist. Initialize it to empty list. And then we had to update our price method, which this one, I don't know why, but I always see so many questions in office hours about this one. So much confusion with this one. A lot of mistakes. The biggest mistake I see is somewhere in this method doing self.basePrice equals, and as soon as you type that equal sign, that's where everything gets blown up. That's where you're definitely wrong. That base price can't change. It's the base price. It's unchanging unless you call set base price. That's the only way to change the base price. So if you're changing this base price, you're wrong. And that's a very common mistake on this issue. Now, this is when we were first learning about references, the heap, and heap space. And once you say self.basePrice or on the homework this.basePrice equals, you're making a change in the heap. And that's one thing, it was the new thing on this homework, on this objective, is making that change on the heap through a reference, following a reference to the heap, and making that change that will persist across method calls. You're actually changing the state of the program, and that's not what this method should do. It should just return the price of the item without making any changes to the item itself. So we never want to do base price equals. What we want is a temporary variable, computed price, I'll call it. Set that equal to the base price to initialize it. iterate over my modifiers. Computed price equals mod.update price. And this is where you can start seeing some shortfallings of Python here. I don't even know if I could call it shortfallings, but a feature of Python, I'll say. Modifiers is a list, and we can actually do type hints, what we call type hints in Python. I can give my variables types that the IDE will look at and enforce. Not really enforce, but give me a heads up. Like, hey, you said that was going to be a list, but you're treating it like a dictionary. Maybe you want to go check this out. The code's still going to run fine. The interpreter is going to ignore these type hints. But it can help you out to get autocomplete, to get some extra help from your IDE, things like that. But I can't say this is a list of modifiers. I can't do this. I don't have a way to give that a type, not that I'm aware of anyway. So when I'm iterating over this list, since this list can contain a mix of any type ever in existence, my IDE is not going to know what type this mod is, even though I know it's going to be a modifier. Python doesn't know that because Python's going to let you mix and match types all day long. So I don't get any type. I don't get any autocomplete here, so I do actually have to type in update price. I have to make sure I spell it right. I have to eyeball that. If this is spelled wrong, it's not like I'm going to get an error. That IDE can't help me here because it doesn't know what type that's going to be coming out of the list. So this is one of the things that makes Python tough to work with when you have larger programs with a fair amount of complexity. It gets a little tougher. It's up to you to make sure you're doing things right because Python can't help you as much as Scala does because Scala is compiled and strongly typed. That combination of two things gives us a lot of extra help on the compiler side while we're writing our code. Python is just not equipped to be able to help us out like that. And the two big mistakes that I see with this is putting base price here, and then your modifiers, your sales don't compound properly, or putting base price here, which, as I already mentioned, modifies the state. And once you call price twice in a row, that was my common go-to in office hours. I would say, in your test, you're checking the price, right? Copy and paste that and call price twice in a row. We agree that it should return the same value, right? Yes. And then they run it, and it's returning different values. It passes the first time and fails the second time. And I say, it's because you're modifying the heap. Check out what you're doing. Make sure you don't modify the heap. So that was the lesson that we learned in this one. And by the way, this is a flashback to the accumulator pattern. You initialize your accumulator to some initial value. You go through your loop and accumulate values, and then return the value of your accumulator. So we got a lot of extra stuff. Of course, the 116 stuff. References, the heap, inheritance, polymorphism, and I guess a non-CS topic of just making sure that you're compounding your percentages properly by putting computed price here instead of base price. So there's a lot of extra stuff, but the fundamental core of this, the foundation, is the accumulator pattern that we hammered into your head in 115. And then finally, a tax method. F tax. Tax equals 0.0 for mod in self.modifiers. Tax plus equals mod dot compute tax. I got to memorize that, and I have to make sure I type it exactly. It's a lot of pressure. Self dot, and this was probably the common mistake here, was putting base price here. You want to make sure that you're computing the tax of the final price or the sale price. So if I'm buying an item that's a $100 item, but it's marked 80% off, and I'm only paying $20 for it, I'm only paying tax on $20. I'm not paying tax on $100. I'm going to be quite upset if you're charging me tax on a $100 item that I bought for $20. It's not how taxes work, thankfully. It's not how it works. Thinking of Amazon, where there's always some ridiculous price and it's always crossed out and it says 45% off or whatever, and that's the final price. I'm not paying tax on the price that's crossed off. It's just not how it's going to happen. And then also making sure that you're not paying tax on tax. So a few things to set up here, making sure that this isn't like plus tax. I don't know if I've seen somebody do that, but we definitely don't pay tax on tax. Tax does not compound. So making sure that's all set up the right way was the task on this one, and then return tax. Just setting up your code to reflect the real world things that we would expect as a customer. I don't expect to pay the price, to pay tax on the original price. I'm paying on the price that I pay, and I'm not paying tax on tax. Two things that we expect as customers, setting up your code to reflect those two features is very important. And the last part of task 2, we will get to the end of task 2 here. Subtotal, total, subtotal, tax, and total. You just set these up, def, tax, def. The first two I'll put placeholders, but total we can finish right now. Self dot subtotal plus self dot tax. We're just going to call those methods. There's a lot of students I've seen recompute these things in total. You already wrote methods to compute those things. Don't compute them again. What we want to do as little work as possible. Just call the methods you already wrote. Subtotal, sub t, subtotal. I don't know, I have to name, actually no, I don't have to name it something other than the method name. Subtotal equals 0.0 for item in cart, self.cart. Subtotal plus equals item.price. So we're going to sum up the prices of all the items in the cart. Again, it's the accumulator pattern, but this one's a little bit easier than the one we just saw. It's not too much to think about. You're just initializing at 0 and summing up all the prices of all the items. Same thing with tax, but let's make our variable names make sense. Tax, 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 tax. That's task 2. We won't have time to set up the state pattern, but the state pattern isn't, since we can already mix types, it's not super interesting. It is interesting just in the fact of the state pattern, but not too much different than what we did in Scala. So I'm fine that we didn't get to it. So the big thing is, this is the syntax for inheritance in Python, and you have to explicitly call the superconstructor with this syntax. All right, any questions on anything? Okay, that's 116, that's it. Good luck on the future, good luck on the exam for those of you taking it. Good luck in 220, 250, and just good luck on everything. I'll probably see you around at some point. Take care.